operate. Ladies and gentlemen, today we'll be considering escape velocity. Escape velocity. Have you heard and realized that the law of gravity by Isaac Newton is real? That whatever goes up must come down, but that law is countered through the physics of escape velocity. With the appropriate energy propelling an object out of Earth's space, it can overcome the Earth's gravitational field. So by definition, what is escape velocity? Escape velocity is the minimum velocity required for an object to leave the gravitational field of an astronomical body permanently. If you look at it, the football player, he kicks the ball, he has to apply a minimum velocity, an amount of velocity that can propel that football to escape the gravitational field of the Earth. And once it can escape the gravitational field of the Earth, it will float at infinity. Now, the work done in carrying a mass m from a point at a distance r from the center of the Earth to a point outside the gravitational field is given by work done is equal to F of r, which is applied force, which is equal to work done to overcome the gravitational force of attraction on the body in order to move it outside the gravitational field. And hence, the object could be satellite or rocket, and the astronomical body could be the Earth. What are the triune components of escape velocity? When we speak about escape velocity, three things are very important. Number one, the bodies involved, the masses m1 and m2, or uppercase m and lowercase m. Then number two, we have the distance apart, which is the lowercase r, the distance between m1 and m2. Then number three, force is constant. The applied force gives us the third triune component of escape velocity. Mathematically, the force equals gravitational constant, which is Earth's gravitational constant, multiplied by the mass of the Earth, multiplied by the mass of the body, divided by the distance of the bodies apart, the square of their distance. Work done, therefore, is equal to G m1 m2 multiplied by r over r squared. But work done is equal to G m1 m2 divided by r. So this work done is equal to the kinetic energy of the mass m, which is the mass of the other body. Remember uppercase m or lowercase. Remember uppercase m or m1 denotes the mass of the Earth, while lowercase m or m2 denotes the mass of the second body. And therefore, the kinetic energy of the mass, which is the mass of the other body, having a velocity v of e, which is escape velocity, at the point A, distance r from the center of the Earth. So at the point from the distance r, so therefore kinetic energy half m v squared is equal to G m1 m2 divided by r. Therefore kinetic energy is equal to work done. Equating and substituting, half m2 ve squared is equal to G m1 m2 divided by r. Divide through by m2, so that I have v squared is equal to 2gm divided by r, so that escape velocity is equal to square root of 2gm divided by r. Assume the body to be at the surface of the Earth, where lowercase r is equal to capital R. Then by substitution, escape velocity is equal to square root of 2gm divided by r. But m is equal to acceleration due to gravity multiplied by r squared divided by Earth's gravitational constant. Therefore, escape velocity will equal square root of 2g multiplied by g r squared divided by rg in the square root of both sides. Hence, our final formula for escape velocity is equal to square root of 2g r. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.